All right, people, welcome and good evening. Welcome to our meetup, the 11th meetup. It feels a bit like it's the 13th meetup because we were having some technical difficulties as last time. But let's not think too much about that. Um, let's say it's a bit different than we're used to. The past 10 meetups, there was a crowd from, let's say, 20 to 50 people, engineers, developers, architects sitting in the audience, and there was a lot of interaction. Um, but this time, because of the COVID situation, we decided to do it like this. So instead of the audience, I have a camera in front of me and a second camera to the left. But I think we can have we can bring you an exciting a lineup of speakers. The two speakers we have for tonight are Jeroen van Disseldorp and Richard Bosch. They live and breathe Apache Kafka, so I think it will be interesting for you all. So without further ado, I want to introduce Jeroen van Disseldorp, CEO of Actual, that's going to speak about starting your Kafka journey.
All right. Thank you very much, and welcome here this evening on the virtual Kafka meetup. It's a bit awkward to not have any public to talk to, but we're going to try it anyway. Tonight is all about starting your Kafka journey in the cloud. And we'll come to on why starting your journey in the cloud is an interesting topic. But to illustrate, what the benefits of cloud for Kafka are, as opposed to running stuff on-prem, we're going to follow a main character throughout a story this evening. So, without further ado, let me introduce you to our main character of this story. Meet Franz. Franz is an interesting young fella. He was born in Prague and soon got interested in writing, especially in writing code. And Franz has written code in just about any language, in Java, in Scala, in Rust, in Golang, you name it, and Franz has written code in it. So soon after that, Franz decides to go to university and study computer science. Because he really wants to live and breathe computers, and he wants to get educated in that. And obviously he has talent for it. So he's so good that after a few years' time, Franz graduates with honors and is ready to start his professional career. Now when he does so, he gets hired by a company called Acme. And this is a company making exabucks, which is a bit which is a bit awkward. The only person in the audience here starts to laugh. But it's which is exabucks is not some new Bitcoin that we invented, but exabucks is just a huge amount of bucks. So this is more than giga and terabucks. But Acme is a financial services provider that sells white label products to its customers, but under its own name. So the way it does this is by having these white label product providers in the backend. So I drew a couple here. There's one for car insurance, there's one for credit cards, and there's one for bank accounts. And these products then get resold under the Acme Corp's name to their customers. Now, in order to be in touch with their own customers, they have a call center which customers can call, and they can get services on the existing products that they have, or they can buy new products. So there's a sales and a service department there. And there's also a mobile app that is used for all customer communication. So customers can get an overview of what products they have, but they can also interact through the app with their products. Well, the year before Frans joined the company, they started a digital transformation program. Because Acme was a bit of a brick and mortar company. They had lots of different stores all over the country. But obviously there was a big digitization going on in the financial sector. So digital transformation was the big next thing. But, you know, the company was pretty clueless on how to do so. So, you know, it was brought forward, but, you know, most employees in the company did not have much faith in that particular program. But nevertheless, they did write a vision paper where, you know, becoming data-driven was the main theme. And they envisioned that Acme would become data-driven by introducing a bunch of tools to host data. So data warehouses, databases, but also data lakes. Because, you know, what is a company without a data lake nowadays? So this was all being put in this big grand vision, along with all the data sources that they would need to capture data from, telling them all kinds of important stuff about customers, processes, applications, but also integrating all kinds of external sources. For instance, government information that sends updates on the citizen registry when somebody moves, but also market information, weather information, which can be correlated to car insurance, of course. So all these kinds of data sources would need to get hooked up, and this was the main vision of Acme. Now, when Frans joined the company, his main task was to set up one of the most crucial projects in the company to create the 360 customer view database. There was a lot of application for marketing. Marketing wanted to know the customer better. They wanted to know on what channels the customer move. They want to know what types of behavior they have, and they also would like to know in the future, you know, how to predict next steps for customers. So Frans, welcome to the club. This is your desk. Go ahead and create us this 360 customer view. So Frans starts to look around. He works in a team which is supposed to handle this. And together with his team, he starts to look at where information within the company is, with which he can build his 360 customer view database. Well, they position it somewhere in the company and then start to draw, you know, where information should come from to build this customer view. And then soon they find out that the information that they need to put in this 360 customer view comes from all over the organization. It comes from the data lake, it comes from different warehouses, and it also comes from a couple of legacy databases that they have. And then Frans starts to wonder, because, you know, if you want to integrate all this data, some data is on a monthly basis, other data is on a daily basis or an hourly basis. Some data is described as JSON, others as strings, field names, they don't match up. Data qualities are different. Some sources have overlapping information with other sources. So that's a fairly big mess to get yourself into. But Frans wonders, you know, if this is going to be the data-driven company, how can we then do this integration? Because, you know, is this symptomatic for this particular use case, or is this a more structural theme within the company? So it starts to look at how Acme does its data integration in the wider sense. And he soon discovers that data integration is a big mess. So the car insurance information and the bank account information, those are being imported into data warehouses periodically. The car insurance information is imported on a daily basis, whereas the bank account information is imported on a bi-hourly basis, so every 30 minutes. And the credit card information is a rolling stream with transactions just coming in, which are being stored in the local data lake. The fact that the bank account information comes in every 30 seconds also poses challenges to the call center, because sometimes customers call the call center to ask about a particular transaction, but then the call center employee is not able to even find the transaction that the customer is talking about because there's a refresh rate of every 30 minutes. So if you call within that 30 minutes, the transaction may not even have been imported into the local database for the call server's employee. Well, all the internal sources, it's not much better. So there's a bunch of sources being inputted into the data lake. There's other data sources being imported into the data warehouses. Some even have duplicate targets. And for the external addresses of the external data sources, it's not really much better. Governmental information is being imported into the data warehouse, but market broker information, weather information is being stored in the data lake again. So all in all, Frans concludes that this is, fairly a big mess. So how to improve on this? Because besides the fact that this would be technically messy, maybe, Frans also thinks about how can we, with all this data available, ultimately provide business value. And he starts to imagine, what accuracy, but also what timeliness of data means for the organization. And he does this on the basis of a single data event or a business event that takes place in the organization around the customer. So as soon as that customer event is there, it needs to be imported to Acme. So it needs to come from this external data source. But now with all the batch imports that are taking place, this obviously takes some time. So data is captured sometime after the real event took place. And then based on yet another periodic frequency, the data is analyzed. So maybe a couple of times a day, the data is analyzed, and from that come certain conclusions, certain actions, and these actions are being put in motion, but often, the event is already long past. And then, using this curve, Frans can indicate already that a lot of the business value is lost as soon as, you decide on taking an action. So how to structurally improve on this? Because data processing is obviously crucial for Acme. Acme wants to become data-driven. They want to provide value. They want to be one of the market leaders. But this data integration is so messy that this is really holding them back. But then all of a sudden, Frans gets an email from the Kafka Utrecht Meetup where they talk about real-time data streaming with Kafka. Well, he doesn't know what Kafka exactly is, but he does like the term real-time and data. So he starts to look into what this whole data streaming thing actually is. So reading up on Kafka and data streaming, Frans finds out that a data stream is really an endless list of messages with a certain name, often pictured like this, where you have a long list of messages where producers that detect new events, they append that event at the end of the list, and consumers, they take events from that list, do a get next, so to say. They process the event, get next, process, get next, process. So consumers may be anywhere within that data stream, and producers are always by default at the end. So he reads about this structure of publish subscribe and how this works, and he sees that producers and consumers do not know each other typically. The producer does not know if there is a consumer, and if so, who the consumer is or who the consumers are. And consumers, although they get the data from the producer, they never acknowledge back to the producer that they have seen this data flung by. So they reply or they act, but they do not respond directly to the producer. Now, having this schema of producers, an event platform, and consumers is something we call data streaming. And ultimately, if you have this whole setup, then data streaming becomes, the continuous ingestion and processing of events. And that takes place along a fixed process. So you first collect, ingest the data, you structure it to be processed, you then interpret it and associate it with other types of data. And then finally, based on certain options that you have, you can make a decision on whether or not to act and put a plan in motion. And this is something that Frans would like to introduce to Acme as well. He likes the pattern, he likes the fact that it's real time, but of course, Acme already has a bunch of legacy systems, so how to integrate this next to the existing systems. So he looks up, what makes the existing system so different from introducing a Kafka in the organization. And then he soon learns that if you do data processing right after the event was created, we call it event-driven processing. But if you store these events in a data lake or in a data warehouse, it becomes like batch processing X amount of time after the fact. Or maybe if you store it in the data lake, it becomes historical data processing. So the data processing on the batch and the historical sides don't change that much. So Kafka is really something as an add-on to the existing data landscape. And that is something that he likes because his project is kind of new. They want to introduce something in the company that is not there yet. So anything that he could put next to the existing IT would almost be accepted automatically. So he starts to envision the emergence of a streaming platform for Acme. But of course, he wants to have like a nice, thought model of what this streaming platform is for Acme. So he envisions the streaming platform to be a marketplace where systems exchange business events at the moment they occur. And a business event is obviously something very loosely defined as an event that happens or takes place to which certain other parts of the organization wants to respond. There's obviously 3 types of interactions, as we all know in this Kafka Meetup group. You have your producers that detect an event somewhere else in the world. It can be inside the company or outside the company, but it's detected nonetheless, and then being put in a single message and then placed on the Kafka platform. Consumers, they have an interest in certain types of events, so they subscribe to one or more topics, and then as data gets produced on these topics, it flows into the consumers for them to handle. And there's a third pattern, which is called a streaming application. These applications combine the two. They consume from one or more streams, do calculations, aggregations, and the result is then placed on one or more other topics. Now he likes this pattern. He likes the fact that this meta model is there. This could be really something for Acme. So how to proceed then? Well, obviously the first step would be to select a streaming engine, because a streaming platform is nowhere without a streaming engine. So he looks into the different options that are out there, being the SaaS options, open source options, and proprietary options. He quickly discovers what each option entails, and then starts to weigh what Acme could really use and how to get going quickly. And then he selects Apache Kafka, being open source, being really popular, as the streaming engine that he would like to get experimental with. So he selects Apache Kafka as the preferred engine for data streaming, and then starts his technical journey. But Frans quickly discovers that Kafka can be very difficult to start with, because once you download it, you first need to somehow configure it. You need to know how to deploy it, especially if you go beyond your single installation on the laptop. You need to know how to maintain it. It can be brought live on some environment, but the day 2 and 3 maintenance, those can be really challenging, let alone the month 2 and the month 3 maintenance. What to do there, where to look for, what will you encounter, what types of system failures can happen. Obviously, he wants to know how to monitor the system, how to secure it, how to integrate it with all kinds of data sources, and also how to scale it if it becomes successful. How can you scale Kafka then across the organization? So this is really difficult for Frans. He wants to move forward, but this seems to be really a steep learning curve. And he wants to get around the learning curve. And then he discovers that Kafka can also be bought as a service if you host it in a particular cloud environment. So that's really cool. He starts to dive into that as well, and quickly finds that around Kafka as a service, there's a bunch of different vendors that all offer you Kafka as a service. These vendors, they can set up the full environment for you. There's no upfront configuration required. The deployment is fully automatic. The maintenance is obviously included in the service. And there are different monitoring options available for you to hook up your favorite monitoring system to your Kafka as a service in cloud. So that's really cool. And Frans is starting to get excited. And he would like to get experimental with Kafka as a service with any particular provider. And, well, not so coincidentally, he is pointed to a trial button because it's really easy with Kafka as a service in cloud to start your free trial. So this is what he does. He signs up for Kafka, and then obviously he starts his trial. Now behind the scenes, his Kafka environment gets created in the cloud. Cloud providers often use data centers with different availability zones. So here you have a typical cloud provider in a typical region with 3 availability zones. And the nice thing about Kafka is that it can spread load across these availability zones, and it can also protect you against outages in a particular availability zone. So building on a generic Kubernetes in cloud, the cloud provider deploys all the zookeepers necessary for Frans's environment, and then obviously all the Kafka necessary for Frans's trial environment. And this is something that he really likes because, without technical knowledge, without having the steep learning curve, he now has a fully running, stable Kafka environment to experiment with. So the managed Kafka, check. He likes the fact that the system is automatically spread across 3 availability zones because that gives him better uptime guarantees, availability guarantees. And of course, the system is also able to do automatic scaling. So as load would grow, the system could automatically grow with him. There's also a bunch of standard integrations available because in this picture you only see Kafka. But obviously around Kafka there's a bunch of tools that are regularly deployed alongside Kafka. So a schema registry and a REST proxy are also standardly available in the cloud environment. And very important, the whole security bit is taken care of. Kafka is difficult to set up around security, is something that Frans read. So this takes away that burden from him, automatically giving him a secured environment. So then the only thing that Frans needs to do is to focus on the applications. So he first starts to write a producer. He writes just a simple test consumer. And before you know it, Frans gets the information flowing across his Kafka. And this is something he really likes because he envisioned first that this would be a cool platform. Then he ran into a wall of all kinds of technical things that he would need to know about in order to run Kafka on premise. But now all of a sudden, with a few clicks on a button, he has this full-blown Kafka environment, and he just needs to focus on writing his business logic to be able to stream his data. So obviously what happens is Frans really falls in love with Kafka as a service. The benefits far outweigh the benefits of cloud far outweigh the aspects of running Kafka on premise. So this is something he really likes. It's easy to get going. Obviously, then he has to convince his team. So the first thing that he does the next morning is to demonstrate his Kafka as a service environment for his teammates, which he works with on the 360 Customer View project. Well, after some experimentation of their own and seeing the demo, the team is really enthusiastic and they decide to adopt Kafka for their 360 Customer View project. So what they do is they start to work with Kafka. They have a few discussions on data ownership, because around customer data there's always a lot of points to discuss. Who gets access to what data? How will we as technicians step out of the equation of assigning the rights for an application to access the customer data? This is something that they discuss how to do that procedurally, and also where to get the workflow, where to get the approval with what particular manager before an application is allowed to access a particular topic. And they set up a CI/CD environment in Acme for their test runs that they do at night on the Kafka applications. So they start to create the systems for the 360 customer view. And they start out with, the data integration aspects of those systems. So the first thing that they do is to set up a data dictionary. And a data dictionary around Kafka is really important because your systems connected to Kafka don't know each other. So the only thing that you can agree upon is the data contracts between the applications. So the data dictionary around the 360 customer view is invented. What is a customer? What is a product? What is the view in the customer? What is the life cycle? What are the life cycle steps of a customer? That is all being discussed and being put in this data dictionary. Then a bunch of applications are written to import the data from the white label product providers that they have. Upon each import action, the data is automatically cleaned and put in the format that others would expect, so adhering to the data dictionary, and then being spread across the Kafka bus. And obviously the 360 customer view is the data store where everything comes together. So it subscribes to all the topics which contain customer data according to this data dictionary, and then store it accordingly. And even though marketing has direct access to this particular 360 customer view database, often they need to respond directly to particular customer events. So they also hook up to Kafka so they can respond in real time to those customer events. Now this is really cool because Frans started out with this project thinking that this would be a tough nut to crack. This whole Acme has a pretty nice vision, but its data integration was really lacking in features. So that's why introducing Kafka could solve a lot of these features locally for their project initially. But as we find out, there's more use cases to be put on the platform. But for now, the team is really happy. Frans's team is the first team that brings Kafka to production and brings a use case on top of Kafka to production. So they have a big celebration on Friday afternoon. And I'm going to tell you lots more about this whole Kafka journey after the next talk from Richard Bosch. See you in a minute.
Okay, and welcome to Hooking Up with Kafka Connect. What I'm going to talk about, first a bit about me, small intro, and we come to a common issue for Connect, which becomes its case, and then how to hook up your Connect. So first, a bit about me. I'm a software engineer here at Actual. focus on integration. I help develop the clients, the Connect implementations, and in my spare time, I've got I do photography. I love aircraft and spacecraft, reading, cycling, and well, just to take life a bit easy. So I love aircraft and photography, so I became known as something like this. You will either see me with airplanes or with the camera. But sometimes I also have my downside. So when I had a big surgery coming up, I decided to combine those two and go to the Southeast Air Show in on Manston Airport in Kent. This is, for me, was just a trip. So where's what's Manston? Well, it's close to Ramsgate and it has a nice harbor. So I decided to plan my trip. So how to get there? Well, there is a KLM City Hopper going there. You need to book a hotel, so I did that. And I was really planning to check out the town. First get something to eat, go into the pubs, see what else is Ramsgate's got to offer. And of course, in the preparation, I bought a ticket for the air show. Everything set up, really nice to get things planned, and let's go. So here is a map of the airport and Ramsgate. I land, and I'm at the airport. And then the hotel is in Ramsgate, and I realized I had no idea on how to get there. I just assumed there would be a taxi and there would be a bus service. It turns out that it's a small airport, and I was lucky to get a cab to the hotel. This part I always remember because when it comes to Connect and integration, this situation pops up. Someone introduces Kafka in their cloud or on their on-premise system, and then the engineers, the architects goes, let's make a real-time dashboard. Let's make a streaming app or multiples. Let's join them and then do some analytics. And they all connect to Kafka to process the data, to make sure that it's persisted and that it's generally available to anyone else who wants to use it. But they then come into this, get this account that we've got Kafka and a current situation of systems that are not connected to Kafka. So we've got a legacy analytics app, we've got some legacy processing apps, and it uses the database to store their results. So how do we get the data from the legacy systems into Kafka so that people can start building their apps? So we get the data, we focus on the database. The database contains all the information. So I want to load from a table and put it in a topic. Table Y, and Kafka will have a table Y topic where all my applications can start reading from it. So I design my application, open a connection to the database, determine when I last accessed it, read all records since that last access, convert it into JSON, write it into a topic on Kafka, set the timestamp for my last access, and then keep looping this logic, reading, converting, writing. And this works. So I deploy an application in my cloud. I can use anything for it, Kubernetes. I can use another app server. Doesn't matter, and it works. But now I want table X to be synchronized, and then someone wants to synchronize table Z. This setup occurs quite often. So let's take a look at the application. Maybe I can just copy it and start a couple of other applications which read from another table. Well, of course I can do that, but that's a lot of overhead. So maybe take a closer look and see if I can find some solution for this. So we go back to the logic, and we see actually that a connection to database, timestamp read, and reading then since the timestamp is extracting the data. We've got a small conversion to JSON, and then we write it to Kafka, which you can consider a load. This is a very generic approach. You can make this configurable. And when you say something like this, you get a case for Kafka Connect. So what is Connect? Well, it's a tool for the scalable and reliable streaming of data between Kafka and other data systems, databases, queues, anything. It is often thought of as an ETL framework, but it's mostly focused on extraction and load. Transformation you do with microservices afterwards when it's in Kafka. It's a plugin system. The plugin contains the implementation on how to connect to the external system. It speaks the dialect, so it's a plugin that says, go to database, read from MQ, go to Snowflake, and put the data there. And it uses a configuration to instruct how to use the plugins. So now in the company cloud, I introduce Kafka Connect, and I've got a couple of connectors in there called table X, table Y, and table Z. They go to the database, and they go and it connects to Kafka. This connect system is nice, but what is a connector then? Well, a connector is this. A small configuration, you give it a name, in this case synchronized table Y, a class that implements it, it's the plugin, how many tasks you want it to run, parallelization, the target topic, the database connection in this case, schemas, the query to get the data. One field that we need in this one is the modified date, so that we can select from the last data read. It will save that, and the next time it does a read from the database, it uses it. So we specified the field, modify that. That's the column in the data in the table to use. And we use JSON converters to create the key and the value on the topic. If you want another connector, you copy this configuration, you change the values to whatever you need, provide it to connect, and it will start running that. So Connect itself, how can I deploy it? It has two modes. One mode is the standalone mode. You configure that one using a property file or multiple properties files, and you can modify runtime the behavior via REST API. Any changes made via REST are not persisted in standalone mode. The plus is you don't need any additional topics inside your Kafka broker, and offset will be stored on a file system, so you can run it anywhere you want, mostly for development or small scale connections. But sometimes you want to run high load parallel with parallel processing, then you come into distributed mode. You've got multiple instances of an Connect running. They work together, and they are configured using a REST API. Configuration and status are persisted on the Kafka broker, and the offset is also on a dedicated topic on the Kafka broker. This is for, as I said, scalable solutions, parallel work. So in the cloud, we set it up. This is the standalone. So we've got the Kafka cluster, broker 1, broker 2, and 3. Can be anything we want. It can be Kubernetes, but it can be just a Java on a VM. The standalone mode, it will also be anything you want. It will be in a VM, or you run a Docker container, and you set it up. Only thing it needs is full connections to the broker nodes. In the distributed mode, we've still got the Kafka cluster, but now we've got also a Connect cluster. So the distributed mode, you see that they communicate with the broker and with each other. So if you set this up, you create a VM or you set up your Kubernetes in a stateful mode, it will start up Connect, it will go to the broker, it will get its configuration, and it will notice that there is another distributed node. They will communicate with each other, and when someone gives it a REST call to any of these nodes to create a connector, they will decide among them who is going to run it. If one of the nodes goes down, for whatever reason, those tasks will be redistributed to the remaining instances. So to set this up, you need network connectivity to the broker. So the Kafka cluster needs to be reached. And of course, because you're integrating, you need to be able to reach your other data systems. Database connection isn't HTTP usually, so it has its own port numbers and uses a different transport, which might require you to set up firewall rules within your cloud. Because you also go to an external system, you might need a fixed IP address on the outside, so that the remote system can whitelist it to allow access to their system. And the final network mode is distributed mode. Your Connect members need to be able to reach each other. So now we've got the cloud network, Kafka and Kafka Connect. Kafka Connect is now in this network, but it can actually run anywhere outside of that network, as long as you reach them. So we've got Kafka to Kafka Connect is grouped, and Kafka Connect to the external system, in this case, the database. To finish up, I did make it to the hotel, and I did manage to create some great pictures, I think, myself. So I hope this gives you a nice view on what it takes to set up Connect in a cloud and what you need to think of. And now we will continue with the cloud journey.
All right. So after having seen Kafka Connect, we now turn back to the main character of this evening, Frans, who is embarking on a cloud journey with Apache Kafka. Before, in part one, we saw that Frans joined Acme company. He got an assignment to work on a 360 customer view use case. It was a bit of a struggle because the applications inside the company were not really tied up in a proper way. Lots of different point-to-point solutions with different characteristics. But nonetheless, Frans started to experiment with Kafka and convinced his team that this would be a good solution for their 360 customer view project. So all in all, they chose to go for Kafka, and ultimately they went live with their product. And this was something fairly unique within Acme, because not only did they deliver a solution that worked, but they also delivered a solution on time. So that was really something to mesmerize within Acme. And it was also noticed by management, and management started to praise, Frans for his heroic performance in getting Kafka selected and also using it as the basis for his project. And you know how this goes. success has many fathers. So, management boasts the fact that, this Franz is working for their department. And then soon they start to brag about, what other projects you could do with, this particular person in your team. So Franz gets invited throughout the company to do quite a lot of meetups, presentations, demos, all kinds of technical sessions that he gets invited to. And more teams start to look into what Kafka can mean for their projects. Because this is something cool, interesting, innovative. So maybe, this is something to reuse as well. But, even though Franz really likes to talk about Kafka, the fact that other teams start to adopt Kafka does give some headaches. Because these teams, they start to bug Franz. They ask all kinds of, questions because their systems need to be hooked up and how to do this. So, how can I import my data from SAP? How can I import it from DB2? How can I import data from an MQ source somewhere? And how can I import data from Salesforce? In much the same way, of course, you get your export questions. So how can I export my data to a MariaDB? How can I export my data to a ServiceNow installation that runs within the company? How can I export my data into a Splunk topic, into a Splunk database from a log topic? And how can I export my data into an online Snowflake database? All very interesting questions, but Franz honestly didn't have the right answer. But then he remembered Richard's Meetup talk from the Kafka Utrecht Meetup. And he already had a Kafka as a service, so he dove into Kafka Connect, trying to figure out if this could be a tool to install next to his Kafka as a service. And he soon finds out that Kafka Connect is really cool, and yes, it can solve the questions that he was asked. So he logs into his cloud Kafka environment, checks the box for support for Kafka Connect, and off he goes. Kafka Connect is supported throughout his installation. This is really cool, of course, because then other teams and other sources, they can be integrated inside the Acme Corp. So obviously the data lake and the data warehouses and databases that Acme already had, they could be hooked up pretty easily to the Kafka environment. But also the external sources. For many of the external sources, there's already a default connector available. So having these hooked up turned out to be pretty easy. And the same thing holds for the internal sources. There were certain interfaces weren't directly captured by a Kafka Connect connector. By default, the company decided to write a few of their own connectors, and soon all these sources would regularly get imported in real time with the data that they provide onto Kafka. So that's really cool. So in terms of data integration, there are a lot of issues that Franz saw in the beginning when he started with Acme. They were now getting solved. And that's really nice because, as soon as you solve those data integration issues, you can start to think about other types of use cases that you could embark on Kafka. So typical use cases would be, Franz was invited to collaborate in a project around fraud detection. If you have all kinds of customer data, customer behavior, but also customer transactions or customer request forms, if you have those all combined onto a single platform, it's much easier to detect certain patterns that turn out to be fraudulent in most cases. It's much easier to detect anomalies or strange behavior. They of course have a banking app. If you are an 80-year-old lady and you open up your banking app and you do a transfer within 2 seconds, that's not the typical behavior of an 80-year-old lady. So exactly these kinds of things that you can bring into the fraud detection world, and then decide that this is not something that is probably going to be validated after the fact. So that's an interesting area. Another area where Franz is being pulled into is the area of real-time dashboards. where management would like to get updated on the current status of the company. What are the products? What are the risks that we currently run? What is the outline of the funnel? What about the providers? Do they still serve their SLAs? So it's exactly these kinds of things that they want to steer on. And a third project that Frans is being pulled into is dynamic work allocation. By having certain fraud use cases being put at certain employees in the company, they start to find out slowly that certain employees are better at analyzing certain kinds of data or handling certain kinds of cases. So by doing dynamic allocation, they find out that the whole efficiency of fraud detection, but also the efficiency of other types of cases that need to be handled by employees, they gain in efficiency quite a lot. So that's really interesting. So these use cases were all added into the same landscape. Here just shown as one particular icon with the fraud detection, but the overall efficiency of many of the processes within Acme, they greatly improved. There was only one downside, and that is that Frans really became exhausted. His work for all of these projects, yes, it was interesting, but at the same time, he was annoyed quite a lot because now, the integration challenges were solved. They weren't asking questions about, how can I import this or export that. But now it became really a matter of how to support this Kafka as a service platform. Many teams start to ask, how can I set up a producer, Frans? Or Frans, can you create this topic for me? Frans, my application cannot connect to Kafka. Can you help me out? Can you see my data? I just produced something. It should be on the cluster. Is it there? Can you give my consumer access to a particular topic? I don't know how to set that ACL. Can you do that for me? Or I just read past the data that I need to have. Can you reset my consumer offset so I can, rescan that portion of data that I need to capture? And Frans really became tired of doing all this tedious work. So in fact, the whole situation, it became quite Kafka-esque, so to say. As the company matured its Kafka usage, as more and more teams started to get excited about this whole platform, wanted to get on board, Frans really became a bit depressed because he was just overloaded with tedious tasks that he wasn't interested in. So what he did is he, of course, wanted to scratch his own itch, and he started to envision a platform on which this all could take place in parallel. And then he came up with a new model in which, he separates the technical layers from the functional layers in the platform. And the idea was that the maintenance would be done by himself, so he would still do the technical maintenance and now and then take care of some functional issues. But most of the time, he wanted to get rid of all the annoying work that he was burdened with. So he envisioned that all the applications that would connect to Kafka, of course, they still connect to Kafka, do their streaming bits. But he really wanted to have these teams off his back. So he started to design an interface through which the teams could log in. You could have a data owner role, where a data owner has the rights to create a data stream, to assign the Avro schemas to it, and then to just sit and wait for applications to request access. So other people in the organization could have the system owner role or the application owner role. They would be able to log in, register a new application that they want to hook up to Kafka, and then ask for permission to access a topic in either a consumer or a producer way. And then once the request was being put in, the data owner would get a notification asking, this application wants to connect to your customer data in production. Do you agree? Do you reject? And as soon as he would click agree, everything on Kafka would be arranged. So no more command line, no more hassling with technical bits. Everything would just be set up the way it's intended. And obviously, since he started to work with his team on a CI/CD pipeline, he also wanted to integrate features for CI/CD in his own pipeline. The 360 Customer View project does nightly test runs on the import functions that the import applications that they wrote. So we wanted to have a test function or a test script that runs at night that sets up a topic for a particular import task. They would run their test, see if the data arrives on Kafka. If it does, create a successful test report, and then throw away the topic again. And in the morning, they would get their test report, so everybody could see that the changes that they did during the last day were actually, still working in the test as it should. And this is something that he really likes, Frans, because he's an eager guy, and he now has some sort of a outlook on how he can solve, this tedious work that he gotten himself into. So Frans starts to extend the whole platform with all kinds of new features. This is something weird, I think, but he starts to extend the platform with all kinds of new features. His vision is that, as Kafka scales the data, Frans wants to scale the organization around Kafka. He doesn't want to be bothered with all the tasks of those teams. Those teams should be able to handle their own work. They should be able to configure their own piece of the whole Kafka platform without bothering Frans, because he's just simply not the operator that he doesn't want to be the operator that he is today. So he starts to design all these new features that would alleviate his work. So having a self-service interface for all the teams, setting up different metadata catalogs where they can administer their data and do the whole authorization flows, to set up a stream, browse, and search functionality such that teams can just browse the topics that they produce to see that data has really arrived, to have different kinds of client libraries, to have different kinds of utilities, development accelerators, all that could help application teams to become self-sufficient and not rely on Frans to get going on Kafka. And of course, this is a lot of work, but Frans really puts in the hours, and after some time, this whole platform is up and running. And to his joy, he starts to see that use cases get onboarded onto Kafka that he never heard of before. And where in the past it was all about data integration and improving efficiency, now some of the use cases, they tend to deal with growing the business. So this is interesting, of course, because growing the business is a little bit more strategic than operational efficiency. So a particular use case was that the service desk calls would get monitored. Monitored for interesting information. The feedback that customers gave in those calls would get analyzed, and then based upon feedback and also based upon customer behavior, they could start to predict certain customer desires. So they could proactively offer a customer a certain product, and often they would be right about the customer's desire to procure such a product, and obviously this grew the business. So as these use cases, they started to get deployed, Frans really started to gain confidence again that this whole Kafka platform was going in the right direction. The platform also grew in stability, and he saw that Acme really started to embrace it fully. And the use cases became more and more strategic. After growing the business, there was also some strategic innovation projects being deployed on Kafka, such as making data-driven decisions. They were hooking up AI systems, analyzing all the data, seeing patterns. So they would model those patterns and then have them executed in real time on the data that flows on the Kafka platform to predict what a customer would do next, or making really data-driven decisions. They were able to detect problems as they occurred within certain products. And as these problems occurred, they would also be able to fix them pretty quickly. And they discovered, using the customer feedback, that there was a need, a slumbering need across customers to have a web shop where they could just buy products instead of going through the call center. So they implemented this slumbering need in a new web shop, and that also attracted new target groups for the Acme company. So all in all, this is pretty nice. Kafka really became the central nervous system for the Acme Corp, and their performance really soared. Managers were happy, personnel was happy, they were assigned nice work. Technicians were happy because they now had a modern, fully fledged data platform that everybody was hooking up to and everybody was happy with. So for Acme, things couldn't have been greater. So let's see what we can learn from France's Kafka journey. I think what we saw in this particular story is something that we see in normal days, organizational Kafka journeys as well. There's evolution on many different axes when you talk about Kafka. And the first one obviously is the use cases. In this particular story, they started out with data integration, which is somewhat technical, but really into the efficiency bits. If you don't have data integration, you can't do much. So working on data quality, working on getting formats in the right way, that's really has to do with efficiency. After that, you can build it out into the process parts. If you have your data all integrated and readily available, you can start to improve the efficiency of the processes that you execute. Then you can also start to grow your business, to think about how can you predict next steps of consumers, how can you use all that data and build new products or new features in your products. And then finally, how to innovate. So if you start innovating, you tend to think about new market segments, new products that you can introduce. So over time, you see that as the confidence in Kafka grew in this particular story, but that's what we see in the real world as well. As the confidence grows, you start to see new kinds of use cases that give you a higher value. And it's exactly this business value that you can easily see associated with these use cases. So in the beginning, this data integration, it was really about local efficiencies. Frans had a project, his team had a project. They wanted to get rid of some of the challenges that they had. They decided to go for Kafka. It was a local solution with a couple of applications in their own scope. So it was a local decision that would greatly improve their own efficiency. And then as soon as these other people in the department, they became aware of what Frans's team was doing, you would see that they would also have some of these use cases in much the same way as Frans's team had. So the efficiency goal was put more broadly, and a lot of more local inefficiencies were removed. And then as soon as things start to get optimal, then you automatically get breathing space again to think about business growth. Local growth at first, in the customer segment, and trying to see how to optimize certain customers, how to know what their next moves will be, so you can offer them something that they don't know they need yet. But after that could be the more broad growth, so going into new markets, exploring new target segments, etc. And the third axis is the evolution that you see around adoption. Frans started it out, this whole Kafka journey, as an individual. He signed up for a cloud service, started to experiment with it, was enthusiastic. So he then showed it to a project. who then showed it to the rest of the department, who then started to show it to the rest of the enterprise. So this adoption is really typical, and it's something we see in the real world as well. Normally it's brought in with 1 or 2 people inside the company. They experiment and start to create enthusiasm with the people around them. So if there's anything we can learn from this whole case, then it would be that you can start small, and that is quite unique from getting Kafka in the cloud. If you start small, then you can easily show a little bit of business value already. It can be a local inefficiency, or it can be maybe even a technical complexity that you take out of the way, but at least a little bit of business value encapsulated in that individual project. And then, as you start to tell that story to the people around you, then the adoption and the expansion of Kafka grows gradually. And I think this is something really unique to using Kafka in the cloud. Like Frans encountered running into this wall of running Kafka on-prem, there's a steep learning curve involved with managing Kafka. So if you can get a cloud provider to do this for you, that would take away a lot of the learning that you need to do. So it would enable you to, just like Frans, with a few clicks, get a Kafka environment, hook it up to 1 or 2 applications that you write, and just get the business flow, the data flow going, without having to set up the whole cluster and being able to manage it in months 2, 3, and 4. So that is really cool, and that is something that I would like to close off this this whole cloud journey with. But obviously, well, that's not really the end of Frans himself, because some people may like to know what became of Frans. Well, you can imagine that Acme was really pleased with Frans's performance. The fact that he uncovered this great tool to introduce as a data platform in his organization, it got him a Medal of Honor in the organization, and he was awarded greatly. Through his contributions, his colleagues also started to believe in this whole digital transformation program again. And they, with the faith that they gained, they were able to take Acme to the next level of service provider. Well, then Acme left the choice, of course, to Frans. They were really thankful and said, "Frans, you can do anything. What do you want to do?" And then Frans said, "Well, this is, a journey that I really enjoyed within Acme, but I think many more companies in the world would benefit from knowing about this particular journey that we had." So Frans went on to promote Kafka worldwide, and he did so vocally. And then you might think, well, worldwide, those were the days without COVID, without being restricted to your own ethics. Of course, Kafka was promoted in a safe and secure way. But apart from the joking, so Kafka was promoted worldwide. Frans visited literally every city that wanted to host him. He visited every business event where he was invited to, and he really enjoyed that. And he also started to write again. But this time books. He wrote books about his whole journey with Kafka. He also helped other authors to write about their experiences with Kafka. So My First Kafka book came out of that. And around Kafka, doing all these presentations, having all this visibility, he really grew a community that followed and supported him blindly. So Frans ultimately became synonymous with Kafka itself. So you can imagine that, being an anonymous Frans up until then, everybody just started calling him Frans Kafka. Well, even today, he is still remembered for his whole contribution to the Apache Kafka product and to the movement that he got going. So until this very day, his work remains legendary, and he really set up Kafka to be, world domination. Thank you very much.
All right. Thanks, Jeroen, for taking us through Franz Kafka's journey. I think I learned something today about his whole history. Quite some new interesting facts. So his journey is quite interesting, but it's also interesting to talk about your journey. So Jeroen already explained that it's quite easy to start your own journey in the cloud, and we would like to help you a little bit with that. So what I would like to announce here in this meetup is that you can start your own journey on Actual, the platform that is running Kafka underneath. Here you can see how that works. You click Start Your Free Trial. You fill in the form with all the necessary details, name, company, email address, etc. And don't forget to enter the promo code. The normal trial is for 14 days, but when you enter promo code Meetup30, you will get a 30-day trial. Of course, let us know why you are evaluating the product, accept the terms of use, and click sign up. What will happen then is that you will receive an email. We want to verify your email address. As soon as you have verified your email address, you will receive an invitation as soon as your trial environment has been delivered. In this email, you will find the URL to your environment, a login name, and a password, a temporary password that you need to change. What you will also find in the email is a care package. It contains some files, some tools that you can use locally to connect to the platform. And as soon as you have logged in, it will look like this. But of course, it will be completely empty. It's your task to, fill the platform, create some data streams, create some applications that produce or consume data. And how you can do this, you can find in the Getting Started section in our documentation website. It offers you a step-by-step approach. You can use your favorite programming languages. All the clients that are mentioned in there, we have open sourced. So as soon as you stumble upon problems, you can look in the source code maybe to find out what is going wrong. Yeah. So to summarize, go to actual.com/tryactual. Use the promo code for a 30-day trial. Wait a bit until the demo environment is being delivered. Log into the environment and use the Getting Started to make the most out of your trial. So this concludes our meetup. Thanks all for joining. It was a bit unusual. I must say I really prefer to have all those geeks in the audience and have more interaction between the presenters and the people in the audience. And of course the drinks afterwards. Sadly, we have to skip that. We have to keep the social distance. And probably will be the same for a couple of months still. So I hereby would like to invite you, if you have an interesting Kafka story, an interesting Kafka journey, and any technical topic that you would like to cover that is interesting for Kafka people, architects, for developers, etc. This can be your studio as well. We have all the equipment. We have a location where we can safely record a video and broadcast a meetup live. So if you want to, be the presenter in the next meetup, the 12th meetup, please let us know in the comments on the meetup website, or just shoot us an email. Thanks a lot, and bye bye. Yeah.